All right. Welcome to your stats warm-up. All right. This is going to be about all different types of confidence intervals and calculating sample sizes and sort of things like that. All right. In January 2010, a Gallup poll asked a random sample of adults, in general, are you satisfied or dissatisfied with the way things are going in the US at this time? And all 256 said they were satisfied, and the remaining 769 said they were not. Construct a 90% confidence interval for the proportion of adults who are satisfied with how things are going. All right, so this is dealing with proportions, and as such, we will be using the 1 prop z interval. All right, so again, that's in our stat test menu. All right, we're not using any of the tests. We're going down here to the interval section, and that would be a 1 prop z interval. Now this asks for x, n, and your confidence level. So our x would just be the number of successes, which in our case is 256. So this would be our x. Our n, the problem doesn't directly give us. We actually have to calculate that just by doing 256 plus 769. Okay. All right, and that gives us 1025. So again, when we're putting it into our calculator here, we've got 256, we've got 1025. The confidence level is 90% according to this one. So let's again just show everything that we're putting into the calculator to get full credit. All right. And then when I have those values in there, all right, it gives me my confidence interval, which is 0.22752 to 0.272. All right, that value right there would be my point estimator. That's the center of my interval. And this is basically saying, I'm 90% confident that the true value is somewhere between, 22%, 23%, and like 27%. I'm just kind of rounding things here. Number 2, does the following situation meet the requirements to create a valid confidence interval? All right, so this is dealing with the conditions. In the National AIDS Behavioral Survey, sample of 2,673 adults, 0.2% had received a blood transfusion and had a sexual partner from a group at risk of AIDS. We want to estimate the proportion of the population who share these two risk factors. All right, so we've got, our conditions, which are random samples and independence between the participants. Now, it doesn't specifically say that this was random, but I think we're going to just say that that one's okay here for right now. We have the 10% condition, which is when you're sampling without replacement. And that's a question of, is your sample less than 10% of the population? 2,673 adults is probably less than the population that we're dealing with here. And then last but not least, there's the 10 success and 10 failure condition. And this is the one that you really have to look out for when you have a really small p. So let's check both of these and see what we actually get. So this would be our Q. All right, so n times p is 2673 times 0.002. And this would be 2673 times 0.998. So this one's going to be plenty large. The question is this one going to be at least 10 times 0.002? All right, and we see that it's not. All right, this one works out to be 5.346. This one works out to be 2673 times 0.998. 2667.654. So this one fails the 10 success, 10 failure condition. So we actually can't create a valid confidence interval. All right. So not met. So we can't use the normal approximation. And the normal approximation is necessary to create a confidence interval. All right. So it means like those values we're getting from inverse norm wouldn't really be valid because our distribution isn't normal. All right. So again, we're not meeting the conditions on this one, so it doesn't work out. All right, PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited. About 75% of Italians can taste PTC, for example. You want to estimate the proportion of Americans who have at least one Italian grandparent and who can taste PTC. How large of a sample must you estimate? How large of a sample must you test to estimate the proportion of PTC tasters within 0.04 with 90% confidence? So this is one of those figure out the sample size problems. All right, so the formula that we're going to use is margin of error equals Z star times PQ over N. All right, this right here is our margin of error, the 4% that the problem gives us. This right here is our Z star. Now, if they don't give you a P, you use 0.5, 0.5 as the worst case scenario. But in this problem, they're kind of giving us this baseline and they're saying, all right, 75% of the Italians can taste it. And we're saying that you have at least one Italian grandparent. So there's some Italian, in you. So we're going to use this as our starting P. All right, so this is going to be our starting P value. All right, and then we can use all this to kind of figure out the rest of it. So margin of error is 0.04. Our Z star is based on a 90% confidence, which means we have 10% left. But when we divide that by 2, we've got 5% on each side. So that means inverse norm of 0.05. And then the square root of 0.75 times 0.25 over n. And we actually have to solve for n there. All right, so inverse norm we can do on our calculator, 0.05. All right, it's negative 1.64, but we're just going to use the positive. So 0.04 equals 1.64 times 0.75 times 0.25 over the square root of n. All right, and then it's really just some algebra work here. So we can multiply both sides by the square root of n and have 0.04 square root of n equals 1.64 square root of 0.75 times 0.25. And then I'm just going to do a whole bunch of this on the calculator. So I'm going to say 1.64 times the square root of 0.75 times 0.25. All right, that's that number right there. And then I'm just going to jump ahead and also do the divide by 0.04. So I divide that by 0.04 and I get the square root of n equals 17.7535. And again, I'm just going to leave it right in the calculator and square it. And I end up with n equals 315.1875. So in total, we always round up no matter what the decimal is here. So 316 people, right? And that guarantees that our margin of error is at least under 4%. If we rounded down, technically we'd be a little over 4%. All right. So this is how this works. Again, when they give you a P, use it. Otherwise, P equals 0.5 is the worst case scenario, right? If they don't give you any information, then you just use 0.5 because that's the worst case scenario. But if they give you something, use it. All right. Sally Sue wants to estimate the proportion of her school with seniors that plan to attend prom. She interviews an SRS of 50 of those 750 seniors in her school and finds that 36 plan to go to the prom. Construct a 90% confidence interval that finds the true proportion of seniors planning to attend prom. Okay, so again, we're still dealing with proportions. This whole front of the warm-up is dealing with proportions. So we're still going to be doing a 1 prop z interval. All right, it's going to want to know our x value. It's going to want to know our n value. It's going to want to know our confidence level. All right, our x is that 36 plan to go. There are 750 seniors, but our sample was only 50, so n would be 50. And our confidence level is, again, 90%. All right, so I can take this over here. I can go to stat tests, 1 prop z interval, and then let's see, what am I putting here? 36, 50, confidence level 90%. All right, and you'll see, again, the center of the interval is at 72%, but then it goes up to, or it goes down to 0.61556, and it goes up to 0.82444. And again, if we're interpreting this, the sentence that goes with this is, we are 90% confident the true population parameter or proportion, because we're finding a proportion here, is between basically 62 and 82%, but we'll be exact, between 0.61556 and 0.82444. All right. So we took our sample, we got 36 out of 50, which is 72%, but based on our confidence level, based on our standard deviation, this is how large our interval needs to be 90% confident that we're actually capturing the true value. All right. Let's take a look at the back. High school students who take a statistics course tend to live happier lives. Yeah, I believe that. When rating on a scale of 1 to 100, past data suggests that the scores have a standard deviation of 5 points. How large of a sample would be needed to estimate the mean happiness within 3 points with 99% confidence? All right. So again, this is another sample size problem. The only thing that changes is what we're using as our standard deviation. So it's still ME equals Z star, but now we're doing population standard deviation divided by the square root of n. All right. Now, 3 points, the problem is telling us, is the margin of error. 99% confidence is what we use to find our Z star. And then our standard deviation is given to us right here. So that's our standard deviation, and we're solving for n, so obviously we don't have n there. All right, so margin of error is equal to 3. Z star, we have to do an inverse norm. And again, if it's 99%, 1% left over, but then that gets split between 0.5% on the left side and 0.5% on the right side. So we're going to do an inverse norm of 0.005. Right, the standard deviation was 5, and we're trying to solve for n there. All right, so we can go to our calculator and do inverse norm of 0.005. All right, we get 2.58. So we're left with 3 equals 2.58 times 5 over the square root of n. And again, this is just kind of algebra at this point. So I could multiply both sides by the square root of n, get this. And then pretty much do the rest of that on my calculator. All right, so 5 times 2.58 is going to be 12.9. I can then divide that by 3. it's going to be 4.3. I can square both sides, and I get 18.49. So n equals 18.49, but we always round up, so you would need to talk to 19 people in this scenario. So again, same process as before. The only thing that's changed is what we're using as our standard deviation. This one dealt with proportions, so we had P and Q. This one does not deal with proportions, so we're using the standard deviation divided by the square root of n. All right, but everything else kind of works the same way. All right, number 6. Computers in some vehicles calculate various quantities related to performance. One of these is fuel efficiency or gas mileage, usually expressed as miles per gallon. For one vehicle equipped this way, the miles per gallon were recorded each time the gas tank was filled, and the computer was then reset. Here are the MPG values for a random sample of 20 of these records. Find the sample mean and standard deviation. All right. So that just involves putting the numbers into L1, which I've already done, and then running stat calc one variable stats. All right, no frequency list. All right, if that's left over from our previous unit, make sure you clear that out, or you can just put a 1 in there because everything is just happening once. Oh, apparently you can't put a 1 in there. I thought you could. Apparently you just leave it blank. And then run it. And it'll give you your sample standard deviation. So X bar is 18.48. And S of X, because we're doing samples here, is 3.1158. Right. Next, it says construct a 90% confidence interval. All right. So with these, all right, we're not dealing with proportions, so we're going to be using T interval. All right. Now, again, kids screw this up a lot because they're picking one prop Z interval. So they're like, oh, I should pick Z interval up here. Nope, we never pick Z interval. All right, you would have to know the population standard deviation, and we pretty much never know that. So you're always picking T interval when we're doing these confidence intervals for means and such. All right, so do not pick Z interval. Do not pick it, do not pick it, do not pick it. We're using T interval. Now, it gives you an option, all right? You can either run it on the data that you've entered, or you can type in the stats. Notice that it's actually filling in the stats for me automatically because I just ran one variable stats, so it fills them in for me automatically. But I could also, just say, oh, I'm running it on my data and L1. See, that's why I thought frequency had to be 1, because there it is. And then set the confidence level to 90% because that's what it's asking for. All right, whether I run it like this, where I just tell it to run it on list 1, or whether I go over to stats and then type in the mean, the standard deviation, the sample size, and the confidence level, doesn't matter. It'll work the same either way. If you're doing it using data, just say like, okay, I did T interval with data, and it's in L1, and my confidence level is 0.9, so that I know that you did that. Or you can say, all right, I did T interval and I did stats. So my X bar was 18.48. My S of X was 3.1158. My N was 20, and my confidence level was 0.90. So basically, to show the work, you're just telling me sort of what you did on the calculator. Just so if something's wrong, I can be like, all right, well, they probably just typed some data in wrong, or they probably did this wrong, or they probably did that wrong. But it gives me something to base it off of, so that if your answer doesn't match mine, I can give you some of the credit. But once I do that, if I go down here to calculate, you're going to see I get my interval, which is 17.275 to 19.685. which is basically saying I'm 90% confident the true mean is somewhere between these two values. This is what we got in our sample, but doesn't mean you're going to get it exactly right. So even though this is what we got in our sample, we're saying the true mean is probably between these values right here. Huh? 7. What critical value would you use for a 90% confidence interval with a sample size of 60? So a sample size of 60 means that your degrees of freedom are equal to 59. So then it's just using inverse t. 90% means there's 10% left over, but it's split between the left and the right. So inverse norm of 5% with degrees of freedom to 59. And again, that's still in your distribution menu. Inverse t, we're saying there's 5%. There's 59 degrees of freedom. All right, so 1.67. We always ignore the negative. So 1.67. We're just looking, when we're talking about critical values, always are positive. All right, so critical value, always positive. Ignore the negatives. Okay. And then last but not least, what critical value would you use for a 95% confidence interval with 23 degrees of freedom? So that just means your sample size is 24. But again, we're going to go to inverse t here. We're going to say that there's 5% left, split between 2.5% on the left, 2.5% on the right. So our area is 0.025. Our degrees of freedom are 23. All right, and we'll ignore whatever negative it gives us, so 2.07. So inverse t of 0.025 with 23 degrees of freedom works out to be 2.07. All right. So this warm-up is just kind of a nice collection of the different, problems that you're expected to be able to do. So we've got using inverse t, we've got a confidence interval involving means, we've got sample sizes, we've got confidence intervals involving proportions, we have recognizing the conditions, and again, sample size, but with proportions here. So this is a nice kind of collection of everything that you need to be able to do from this most recent unit. All right, so if you have any questions, let me know. Otherwise, best of luck, and I'll see you when I see you.